In this video, I am going to go over what I think should be included on every page of the data booklet as some extra writing. Now, with my students, I usually start this at the beginning of every unit or as I go through the unit as things start to come up. But because I don't know where you will be moving or how you will be moving through the units, I am creating one big video that will be linked to each workspace that has all of the writing that I think that you can add in to your data booklet as you work through the course. Now, of course, when you start writing your diploma exam, you will get a fresh data booklet. You are not allowed to bring in your existing data booklet, but this is what I call a brain dump. So what I suggest is I actually tell my students to study what they've written in their data booklets in order to help them have that brain dump prepared for the diploma, and then they can go into the data booklet before they even start writing the exam and add in any additional information that they might need. All right, so let's take a look. I'm going to go through, I hope that I remember it per page, but I might need to flip back and forth a little bit here. So let's start with the periodic table. Now, for the most part, the periodic table can remain as is. You'll notice that all the elements on the left side of the staircase, so all metals, have charges listed. Now, what you'll see is on the right-hand side of the staircase over here, we don't have any charges listed. They're blank. So what I generally tell my students to add in is the charges above the column, because all of the charges tend to be the same per column. I will have them add these in. So you can see -4, -3, -2, and -1. And again, I just add that in just for reminder's sake that these elements as ions do have charges. All right, so I add those guys in, and other than that, I think that the periodic table is pretty well done in terms of writing. So we move on to this next page where we have a bunch of constants. All right, so we have things like specific heat capacity, our electrical potentials, our pressure, things like that, and the units. In this case, I generally don't add a ton onto this page, but I do have some students that like to jot down some of their known formulas on the side here. I'm going to jot down the formulas that are relevant to each unit on the data page that is important there. So I'm going to leave this page. If I forget something to add in, I might flip back to this page, but we're going to continue on. So in the next page here, we do have, again, some more constants. We have our specific heat capacities here. We have our water ionization constant. In this case, because the water ionization constant, or the formula for Kw, is used in generally our unit on chemical equilibrium, I do like to add in that Kw equals Ka times Kb here, as well as Kw also equals our H3O, or our hydronium ion concentration, times our hydroxide ion concentration. Here, we're gonna have to scroll up here. OH negative. Okay, and I'm just gonna get rid of this icon here. All right. So I do like to add those in there. That's just a friendly reminder that if I am looking to calculate anything with base ionization, or if I'm given base ionization and I need to calculate acid ionization, I can use my Kw formulas here. I do have students that like to add in the Faraday's constant, or using the Faraday's constant in the formula, where that equals my moles of electrons equals my current times my time over my Faraday's constant. So some people do like to add that little formula in as well, just as a reminder on this page, with their Faraday's constant listed as well. Okay, then we have our units, our unit conversions. Again, I don't think we need to add anything too crazy there, and we can move on. All right, so with our molar enthalpies of formation, I do like to add in a couple formulas here. Generally, I will add in my, let's just scroll up a little bit, that Q equals, or my thermal energy is going to equal my potential energy. All right, and I generally say that Q equals MC delta T, or MCAT, and Q is equal to my change in enthalpy. Now remember, Q is equal to my thermal energy. Change in enthalpy is equal to my potential energy, or my bond energy. And that is going to equal my moles times my molar enthalpy of reaction. So I generally write this formula at the top. And because when we are using our enthalpy formula, we also have variations of this formula as well. So I'm just going to put these in a new color just so that I know it is a separate formula, not included in our original formula here. Again, don't forget that Q equals MC delta T is my thermal energy, and delta H equals moles times molar enthalpy is looking at my total enthalpy. Again, this is just saying the conservation of energy, that my thermal energy equals my potential energy. All right, we also know that my enthalpy, total enthalpy of a reaction, equals the sum of my moles times my molar enthalpy of reaction of my products minus the sum of my moles times my molar enthalpy of reaction of my reactants, P minus R. If I keep this up here, please remember that any values that you put as a product should be sort of double bracketed. If you have two products, for example, you should be timesing the moles times the molar enthalpy of product A. Then, because it's the sum, you're going to add the moles times the molar enthalpy of product B. Same goes for your reactants here. All right, I like to make sure that this is all listed on this page. This is where I'm going to primarily be using these molar enthalpies. Now don't forget this formula here in green, or a mint color, is your Hess's law shortcut. So don't forget that when you're doing your calculations. All right, now these molar enthalpies take up 2 pages. Again, I generally like to highlight or have my students highlight that, and I'm just going to kind of make this highlighted if possible, that we have 2 water values here. So I usually have them take a highlighter and highlight this section, just indicating that there are 2 values for water, both liquid water and water vapor, and just to be conscious of the values and be very conscious of if it's a liquid or a gas when completing calculations. I generally have my students highlight that to make it clear as day for them. Okay, then we have our solubility table. Again, here I don't get too crazy, but I do simplify this section of the table a little bit. I make sure that very soluble does mean aqueous for the most part, and slightly soluble generally means that it forms precipitate or a solid. So in brackets, I will put AQ, or a solid, to indicate that that will be the state of the product created from this reaction. One thing I also like to keep note of is that many students ignore this statement here where it says group 1 ions. I just make sure that it's super clear that group 1 ions are that first column in the periodic table of elements, so that if I'm looking at solubility, I should be sure to look at my group 1 ions and then the ion that I'm mixing with in order to see its resultant solubility. On occasion, the diploma will throw in some questions on flame color or on color of the ion in solution. So just be aware that this information is provided to you. Don't simply ignore it. Anything in this booklet is there to help you through your exam. Okay, here's where we get into a little bit more of the nitty-gritty. This would be the table that we use primarily in our electrochemistry unit. So when we're dealing with anodes and cathodes and things like that, generally I use the acronym oil rig. Okay, so I always will write down that oil rig at the top of my page. So I will write down oil rig. And again, oil rig means oxidation is losing electrons. And of course you can't see this. Here we go. So oxidation is losing electrons and reduction is gaining electrons. I will have that just for simple reference. Often having a visual aid is super helpful when you're completing an exam, especially in some high stress situations. All right, then I also add in that my SOA, or my strongest oxidizing agent, is any entity that is listed in the top sort of left-hand side of this column. So notice these are reduction half reactions, meaning that these entities are being reduced, therefore they are causing oxidation in another entity, or they are an oxidizing agent. So anything on this left-hand side of these arrows, now often students will take a pencil and draw a dotted line, usually with a ruler, and unfortunately I can't do a ruler on my device here, but they will draw a dotted line representing that anything on the left-hand side of this table is an oxidizing agent, and everything on the right-hand side is a reducing agent. And again, they will add in that the strongest reducing agent happens to be in the bottom right corner. Then, in decreasing strength, these oxidizing agents are the strongest at the top and then go again in decreasing strength. And then the strongest reducing agents are the opposite of that. They will get weaker as you go up the right-hand side of the column. Now, there's a few other things that we need to add in here. We talk about how when we're dealing with electrochemical cells, that we have either anox ate a red cat. So anox being the anode is oxidation, and red cat being the cathode is reduction. Or I have some students that also like using the phrase LIOA GERC. And LIOA is another sort of acronym that is to represent that LIO being losing electrons is oxidation, and GER is gaining electrons equals reduction, okay? And then the LIOA, the part, is that oxidation is at the anode, and the GERC, this K part of that, is that reduction is at the cathode. So I often have students write down anox, red cat. This way, it's just, again, a friendly reminder that oxidation happens at the anode and reduction happens at the cathode. Okay, also, just for simplicity's sake, I have students that write down that my SOA is itself being reduced, therefore this is the cathode. The entity that is reacting on this side will react at the cathode, and they will have here the opposite, that this itself is a reducing agent, it itself is being oxidized, and oxidation happens at the anode. Again, some students do like to add in their Faraday's law here using Faraday's constant, so the number of electrons equals IT over F, or your current times your time over Faraday's constant. They like to have that formula maybe in one of these margins just to help them out with their calculations on the information on the page that is relevant to our information. One other thing I definitely encourage students to do on this page is, again, I don't have a highlighter, but what I do suggest is highlighting some key points here. So the first is highlighting this value. What's going on here? Here we go. This value right at 0. So students will take a highlighter and highlight this value right at 0 just to identify that this is my sort of midway point. Anything above 0 tends to be a strong oxidizing agent, at least on the left-hand side, and everything below that tends to be a strong reducing agent, at least on the right-hand side. So that's the first thing I have them highlight. And then I also have them highlight, probably with a different color highlighter, which I will do. I have them highlight the 2 water half reactions, or the 2 reactions that have purely water on one side of the equation or the other. This just helps us identify water as either an oxidizing agent or a reducing agent, because it can act as either. Therefore, it just helps me pinpoint those as well. I have some students that also like to take some sort of highlighter or pencil and identify some of the ions that exist on both sides of our table. So something like tin 2, for example, they would like to identify that just to make sure that they don't forget that they act as both an oxidizing agent and a reducing agent, especially for questions that involve disproportionation. All right, so let's take a look at our next page. So this page, I'm gonna see if I can maybe turn it. Doesn't exactly look like I can flip this page. Well, you may need to turn your head to the side because I can't get this page turned. But this table as well is used for our chemical equilibrium unit. I do this unit first, however, your teacher might have you do this unit in a different order. But what I like to do on this page here is I like to add in a few things. I like to draw that these top 6 acids are what we consider my strong acids. All right, any of these 6 acids will immediately form H3O. So I just indicate in some way that they automatically will turn into H3O ions because they are so strong that they ionize 100% into hydronium. Then what I like to add in is that, again, I have my strongest acid. Anything on my acid column going down this way gets weaker. Then on my other page, again, I like to add in that my strongest base is in my bottom right corner, and they get weaker as I go up. So I then like to take a look at my Ka values and just make sure that I see that anything that has a relatively high number, so 5.6 times 10 to the negative 2, is larger than 9.1 times 10 to the negative 5, for example. That helps me identify some of these values and understand that they are ordered in this particular way, where my strongest acid is at the top and my weaker ones towards the bottom. Now, again, just because something is classified as a strong acid, the only ones that are strong are in fact these 6, meaning that they dissociate nearly 100%. So the other things that I like to remind my students of on this page here, first of all, is that Kw equals Ka times Kb. We did jot that down on another page, so it's not super necessary to write that on this page here. I also like them to keep note of any amphiprotic entities, so those are entities that occur on both the acid side as well as the base side of this table. However, I do like to add in some formulas that they may be using at this point. One being Keq equals products over my reactants. All right, and Keq can also be known as Kc. Okay, the diploma likes to use C for our equilibrium constant. However, I like to use Keq because it just makes a little bit more sense to me. All right, and then this Keq, don't forget, can be substituted for your Ka. So Keq can mean Ka, or it can be Kb, for example, for base ionization, but we will always have our products over our reactants in this formula, regardless of if it is gas equilibrium or if it is an acid or base equilibrium. So let's take a look. I do believe that is pretty much all that I need to put on this page. Some students will also like to put their pH formulas, so I'm just going to jot those in really quick here. So pH equals the negative log of our hydronium ion. Remember, pH means power of hydrogen, and where we have that extra hydrogen is in this hydronium. So just make sure when you're matching up your pH formulas that you're matching up pH with your hydronium always. All right, then we have our POH, which equals the negative log of our hydroxide ions. And we have our other formulas where our hydronium ions, again, we're going to match hydronium ions with our pH, is 10 to the negative pH, as well as our hydroxide ions, if we're looking to reverse calculate that, is equal to 10 to the negative POH. All right. Okay, so on this page with our acid-base indicators, there isn't too much that I think we need to add in here in terms of writing. Some students do like to just make sure that everything in sort of this left-hand column of each portion of the table represents sort of that pH range that's identified here in the middle. So our, for example, HMV on our left-hand side is sort of representing the pH range on the 0 side of things, and it will provide that yellow color. So I'm just going to erase that because I don't want, if you now know that, you don't need to worry too much about that. And then let's see if there's anything else we need to add in here. These, again, are the colors of our aqueous ions that we have in solution. Again, there's not too much you need to add in here. Just be aware that it is there to help you complete your exam. Let's see. I don't know if we need to add anything else. Let's just go back for 1 minute to, because I do believe I forgot one thing, to our electrical potential page here. Don't forget to identify that our I guess I better get something to write with, that if your SOA is above and to the left of your SRA, this is what we consider to be spontaneous. And if your SOA is below and to the left of your SRA, this is what we consider to be non-spontaneous. So that's a good thing to add into the side there, as well as on our strengths of acids and bases page here, we may wish to add in that we have our SA, above our strong base, that this is going to favor our products, or products will be favored, okay, greater than 50%. And again, if our SA is below our SB relatively in our table, that this is less than 50%. So again, that just is referring to our strong acid and our strong base in this table here. And it's just meaning that if our strong acid is, for example, this lactic acid here, and it's reacting with a fluoride ion, that this will favor our reactants, versus if I have my sulfurous acid up here reacting with the fluoride ion, that this will favor products, or the reaction will go greater than 50%. As we go through, I don't think that there is anything else that you would need to add. On the notes pages, some students do like to add in some additional notes there in terms of thermochemical diagrams. So if we just go and take a look there, some students will jot down notes for each unit, and they will have some notes for thermochemistry, electrochemistry, and chemical equilibrium. I generally jot these down on the pages, but at the end of the video, I will complete the extra notes page. These are things that you can consider optional, and they will be on the document that will be also linked into the workspaces for your help there. So I'll write these things down that I think that you could use that are extra formulas, but don't feel like you need to add them in on your notes page if it is too much knowledge. I would focus on the other information that has been provided on each page of the data booklet, just as little tips and tricks to help you out completing your units as you go through Chem 30, as well as on your diploma.